Good evening. Well, this is the 50th Sky at Night. We began the series way back in April 1957, and look how much has happened since then. In those days, space research was still at a very early stage. Well, since, we've had the Sputniks, we've had the American Earth satellites, we've had the planetary probes, and of course we've had the first men in space. But as well as that, we've had a lot happening too in the purely astronomical field. We've had several bright comets, and we've had a close approach of Mars, and of course we've had the total eclipse of the sun last February, which we were able to televise direct. Well, we have done several direct television broadcasts during this time, and for the 50th anniversary of the Sky at Night, we were hoping, and we still do hope, to do another one. So I'm speaking to you tonight not from the studio, but from George Hole's Observatory at Patcham, which is near Brighton in Sussex. Well, George Hole, as you know, is one of our best-known mirror makers and instrument makers in general, and he's constructed this wonderful 24-inch reflector, which is one of the biggest telescopes in Britain and is particularly well adapted to this kind of work because it was built, well, rather specially for lunar and planetary studies. We have used it before. We have televised Venus direct from here, as you know. Well, of course, when we come to this kind of thing, we are rather dependent upon the weather. In fact, we're entirely so, because if you have clouds, there's really very little you can do about it. Now, we've done all we can. We have, in fact, as you can see, we've fixed a television camera onto the end of the telescope, and as soon as anything comes out, we'll be able to give you some direct pictures. But because the weather is so notoriously uncertain, we have cooperated with the Royal Observatory at Edinburgh. Now, at Edinburgh, there is a very fine 36-inch telescope, and we have, in fact, got a television camera fixed onto that one as well. So if the weather is not favourable here, and it doesn't look very promising at the present moment, well, then we do hope that we shall be able to get some pictures from Edinburgh. Well, earlier on this evening, things seemed to be pretty good, and we had quite a lot of clear sky here, and we were hoping for great things. Well, we still do, but at the present moment, unfortunately, we run into one of these banks of cloud. What we planned to do was to start off by showing you some stars, then go on to the moon, then Jupiter, and finally, the most spectacular thing of all, Saturn, the planet with the rings, which never has been shown before on direct television. Well, at the present moment, I'm looking around, trying to shield my eyes from the lights, but we've got quite a lot of light here, of course. I can't see very many breaks at all. The moon is clouded out, and so is Jupiter and Saturn. So I think before we do anything more, we'll just say a word or two about this telescope itself, because it is of rather a special kind. George, what do you think of the prospects now at the moment?
I think we're nearly totally obscured, Patrick. I saw Jupiter a few moments ago. I can see it now.
I can see
it's gone again.
This is one of these infuriating things about which we can do absolutely nothing.
Nothing at all.
Well, they may be better off at Edinburgh. We'll see in a minute or two.
Yes.
And I think, first of all, then, a few words about the telescope itself.
I think so.
How long did it take you to actually to make the entire thing?
I should say getting on for 4 years, but it isn't finished yet.
No.
2 years of that were spent entirely on the glass surfaces.
Yes.
Spare time for 2 years on the glass, spare time for another 2 years at least on the hardware.
And the main thing, of course, is the 24-inch mirror. Of course, that was only part of it, but I take it that was much the most difficult thing.
Oh, yes, because without the mirror, the finest bit of engineering is useless.
Of course, I'm looking all around the time to see for these gaps. Do you think it's any good turning on to the general direction of the moon? Frankly, I don't think it is. I can't see a single star at the moment.
It's totally obscured.
We were hoping to see Vega, which is the bright star straight above our heads, but even that's gone now. No, we've got to abandon it for a moment.
We're blacked out.
Well, we hope
no
something
getting
comes.
away from that.
I think it will do, and anyway, we'll get something from Edinburgh, and we have got a direct recording that we can show you, even if things do come to that pass. So, look, let's say something first of all, then, about the actual optical system of the telescope, shall we?
Yes.
Well, telescopes are of two main kinds, astronomical ones. There are refractors and there are reflectors. Well, the refractor uses an object glass to collect its light. The reflector uses a mirror. Well, there are various kinds of reflectors, too. Most amateurs have got Newtonian reflectors, so-called because they were developed by Sir Isaac Newton, and in that, the light comes down an open tube, hits the big mirror at the bottom, is sent back up the tube, and then deflected into the side of the tube by a small mirror, a small flat mirror, and so in a Newtonian, you actually look into the tube. Now, this big telescope is different from that because it works on two separate systems, the Gregorian and the Cassegrain. Yeah. Do you want to say anything about that before we actually demonstrate how it can be changed?
Well, the Gregorian mirror is in the extreme end of the tube,
And here
Cassegrain mirror is halfway down.
well, we've got the diagram of the Cassegrain mirror on now, and you can see that the convex secondary reflects the light back through a hole in the main mirror. But of course, yours is not quite like this. We've got no hole in the main speculum.
No, but it has an angle flat mirror to send the beam out at the side of the tube into either an eyepiece or this camera.
Well, look, we just show, I think, where the various bits and pieces are. Up here we have the Cassegrain mirror, and the main mirror, of course, is down here at the bottom of the tube, and this is the eyepiece end. What happens is that the light doesn't get quite all the way back down the tube. It's caught, so to speak, and then shot into the side of the tube. And that, at the present moment, is where we have got our camera. Well, now, if you want to use the Gregorian system, well, that's rather different. Your Gregorian secondary is further away from your main mirror. It's near the top of the tube. And there you have a concave secondary. Once again, normally you have a hole in the main mirror, but the Gregorian system gives a greater magnification. It has got its disadvantages, of course, but it has got the advantage that it gives you, well, a bigger picture. Well, in this telescope, when George wants to change from the Cassegrain to the Gregorian, all he does, quite simply, is to slip the Cassegrain mirror down, swing it down into a kind of a sump built in the telescope for that purpose.
There it is, yes. That's the Cassegrain mirror in there.
There is the Cassegrain mirror. Now, as soon as that's done, then, of course, the optical system of the Gregorian can be brought into play.
I'm going back to Cassegrain in case the sky clears.
Well, go back to Cassegrain because it's, for goodness sake, because it's so much easier to get something into a field when the field is comparatively large. And with the Cassegrain arrangement, you have a much larger field. With the Gregorian, with its higher power, then you have a considerably restricted field. Now, I'm going to shield my eyes from the light again because I don't think I can see any break at all. Jupiter is obscured at the moment. I can't see one single star. Can you, George, anywhere? If we can see one star, we'll just get the telescope onto it and give you at least a direct picture of that.
No, we are totally obscured.
Well, there's hope yet. We still have some minutes.
I can see Altair.
Can you?
But it's gone again. it goes before you can get near it.
Well, Altair seems to be about the best bet. I suggest you turn the telescope onto Altair, and just as soon as we get any kind of a picture at all, we can feed it through, so to speak. Any luck?
No, I must be able to see it before I can get onto it.
The trouble, of course. This, of course, is one of the hazards of astronomy. There's just nothing one can do about it at all. The radio astronomers are luckier than us, because they haven't got to bother about this kind of thing. They can operate equally well when the clouds obscure the entire sky. But, as I said earlier, we most certainly can't. Well, I don't know what the situation is at Edinburgh, but if by any chance they have got better conditions up there, well, they'll let us know, and they'll be able to show us Jupiter and Saturn at least. No luck yet?
No, total obscuration.
Right. Well, while we're waiting for a minute or two then, let's try and answer one or two of those, well, many hundreds of questions that we've both had, I think, during the last, well, few years. And that is this business about amateur telescopes, because there are so many people who would like to have a telescope of their own, they'd like to make it, and they don't quite know how to set about it. I've had many hundreds of letters on this score, and I think you've had even more, probably, because you're a mirror maker and I'm not. So well, can you just say something about amateur telescope making while we're just waiting for the sky to clear?
Well, the heart of any telescope is the mirror, and it's quite within the possibilities and capabilities of an amateur to make a very good mirror if he keeps at it long enough. Now, this happens to be a mirror of 12.5-inch aperture, and it is resting on its polishing tool. But the amateur is well advised to stick to 6 or 8 inches as a starting size.
May I break in here?
Yeah.
Where does he get the glass? Because so many people ask about that.
Well, any builder's merchant or glass merchant will order it for him, either with a chipped edge or with a smooth edge. In the latter case, he's got to spend a few more shillings.
Yes.
But he wants to get glass of about 1 inch thick for a 6-inch mirror, and he wants a tool to work it on, which can be a second piece of glass, the same size, or he can build a plaster blank and clothe it with either squares of glass or squares of metal. And he can grind on that, you see. Now, if he...
George, I'm going to break in, I'm sorry, but they've just got a message through from Edinburgh that they've got a picture of Jupiter. So let's go now over to Edinburgh. Yes, there is Jupiter as seen through the big telescope at the Royal Observatory, Edinburgh. It's not a bad picture at all. You can see that the planet is very markedly flattened at the poles, and you can see one of the belts. Can you see that all right?
I can.
Yes. Not a bad picture at all. I can't see any of the satellites, but you would hardly expect to under these conditions. Do remember that at Edinburgh, Jupiter and Saturn are considerably lower than they are from Brighton, because they're both in the southern part of the sky. Edinburgh, of course, is well to the north of ourselves, and the altitude is very much less. So I think they're doing very well indeed to get a picture at all.
I do.
You can see the planet, and you can see the belt. Well, that, I think, is extraordinarily good, and we can at least, that is now a direct picture from the sky. It's not a drawing or a photograph or a recording or anything else. You are seeing Jupiter as it really is at this moment. Well, I'm glad we saw that, anyhow.
I am, too.
Well, we have still got a few minutes left. I still can't see any gaps from here. We got some very good pictures not so very long ago, and we'll be able to show those at the worst if nothing else crops up.
We're clouded out here.
Well, look, wait a minute, there's some kind of a break over there. Can you see it? Look, over there. Yeah. Something.
I can't see anything in it, though.
No, anyhow, I suggest that you swing the telescope down, anyhow, and just get ready.
Well,
right?
onto the moon, if possible?
I think so, yes, because is some kind of a break there, and if we have some luck, well, we may get it yet. I very much hope we do, because this large telescope, with its tremendous light-gathering power, does give you simply superb pictures of the moon, and we have tried it out, and we have got some really good results. And of course tonight the moon is well placed because the terminator, or the boundary between light and darkness, passes over some very interesting areas, and we get these wonderful shadow effects. So I think what we'd better do now, just for the next few minutes anyhow, is to point the telescope somewhere in the direction of the moon, so that just as soon as we get a glimmer we can turn onto it. I do hope we do, but it's so difficult to tell. One can't unfortunately control these things. There is definitely a lightning over there now, George. Can you see it? It's coming out. Yes, there is the moon. I can see it for the moment. No, it's gone again.
It's gone. However,
absolutely infuriating. There's nothing one can do. Oh, well,
it becomes at all possible.
Just got to hope for the best, I'm afraid. Anyhow, let's wait and take advantage of what we can. Of course, the moonscape is undoubtedly the thing one can see in the greatest details, no question about that, because the moon is so much closer than anything else in the sky. Hello, another message from Edinburgh. Yes, right, we've got Saturn now as seen from Edinburgh. So let us go now back to Edinburgh and have a look at Saturn from there. Yes, there it is, and this is a direct view of Saturn on direct television, and it's the first time that it ever has been done. Come and look at that, George. Can you see it?
I am looking, Patrick. It's very, very good.
Now, there is Saturn with its system of rings. Saturn is the ringed planet. It's unlike anything else that we know of. It is a world rather like Jupiter, rather smaller, but of the same essential type. Its globe is made up of gas, and its ring system is made up of thousands upon thousands of small particles, all spinning around the planet. And the rings are very broad, they're tremendously broad from side to side, and when they are opened to us, as they are at the moment, they're well seen. Now, I can just about see the shadow of the rings on the disk. Can you see that all right?
Only just.
I can just about see it there. I say, don't expect this to be as good as the drawing you saw in the Radio Times, obviously, because this is a direct view. But all the same, that is, I think, a rather wonderful picture, and it's something entirely new. I'm extremely glad we got that, because no recording can ever be quite the same. And you are seeing Saturn now direct from the sky. Right, well, I don't think we're going to get any more from there, do you? So let's come back now from Edinburgh. Now, still have a few minutes to try and get this.
The moon is just being awkward.
The moon is just being awkward at the moment, I'm afraid. Well, now, we still have a few minutes to go. We just may get it, but I think the very best thing we can do now is to show that recording that we took earlier. Don't you agree?
I think so, too.
Now, earlier on this evening, conditions were rather better at Patcham than they are now. In fact, they were considerably better, and we were able to see both the giant planets. And so we did make a recording of both Jupiter and Saturn, and we're going to show you that now. It was taken about an hour and a half ago. Conditions weren't really good by any means, but they were reasonable, and both the giant planets were visible. So let's now have a look at this piece of recording. Not quite the same thing as direct television. I've got some clear sky, so let's turn the telescope straight onto Jupiter and have a look at Jupiter on direct television. There it is, and you can see, yes, I think I can see two of the belts. You can see them, definitely. Now, that is, I think, a reasonably good picture under the circumstances. In fact, it's as good as we can possibly hope to get. You can see, to start with, that the planet is not circular. It's very markedly flattened at the poles, and that is because it's spinning around so quickly. Although Jupiter's got the largest planet in the solar system, it has the shortest day, and it spins round in less than 10 hours. The cloud belts are not easy to see under those conditions, but you can make them out in the flashes of good seeing. Of course, there's a great deal of scintillation there. There's a great deal of wavering, too, and that is because of the conditions in the atmosphere. I'm afraid we are having a good deal of cloud trouble. Nevertheless, you can see the shape of the planet. You can see at least one of the belts, and I think you should be able to make out two, running more or less up and down upon your screen. Well, now, having had a look at Jupiter, I think it's time that we tried our showpiece of the sky and had a look at Saturn. Right. Well, now, Saturn is over to the right of Jupiter, slightly higher up, and it is, of course, the planet with the rings. There's nothing else like Saturn anywhere in the sky, and there's nothing like it so far as we know in the universe. It is, I think, undoubtedly the most beautiful object of all. It's a world rather like Jupiter. It's smaller, but not a lot smaller. Its diameter is nearly 75,000 miles. Of course, it's much further away, and so it doesn't appear so brilliantly. But even so, it does look like a rather bright star. It's rather outshone by Jupiter at the present moment, but once you've found Jupiter, you'll have no difficulty in picking up Saturn. So I think, George, just as soon as you've got the picture in, we'll put it straight on the screen. Saturn never has been shown on direct television before, and of course it is a difficult object. Please don't imagine that you're going to get as large and as detailed a picture as that very fine drawing that appeared in the Radio Times, because that was a drawing, and it's a very different matter indeed from getting an actual picture on the screen. There it is, you can see it. Yes, and there is Saturn for the first time on direct television. You can see the rings quite nicely. They're going almost up and down on your screen, and remember, the rings measure over 170,000 miles from tip to tip. Of course, they are also very thin, and so when they're turned edge on to us, they practically disappear. But that won't happen for some years yet, and at the present moment, the rings are wide open. We're still getting a lot of atmospheric trouble, and you can see a good deal of wavering there, but the form of the ring is perfectly clear. You can see also the dark gaps in between the ring and the planet itself. From here, I can just about see the shadow of the ring on the disk, which looks like a hard line. You just get that briefly in moments of very good seeing. Actually, there's not one ring, there are three rings of Saturn. There are two bright and one dim. The dusky ring you can't possibly see under these conditions, and the two bright ones appear as one. They are separated by a gap known as the Cassini division. Also notice, too, that Saturn, like Jupiter, is very considerably flattened at the poles, because it also revolves around very quickly. Oh, we've got some more cloud coming in now, I'm afraid. But there it is, Saturn with its rings. The rings, incidentally, are not solid sheets. They are made up of thousands upon thousands of small pieces of matter, very possibly ices, all whirling round Saturn in the manner of miniature Sputniks. And that, I think, is a very satisfactory picture indeed of the ringed planet, so far as we know, unique in the universe. Well, while that was running, we were sort of looking wildly around the sky, trying to see a break, and we were also trying to contact Edinburgh to see whether they got anything from there. But apparently conditions up there have now gone more or less the same as they are here, and I'm afraid things are pretty solid. George, can you see anything at all?
Vega!
Can you see Vega?
I don't know whether I can get on it.
Right, the star Vega, which is the thing we wanted to show you, it's a bright blue star right above us, as I said earlier on, and with any luck now, we will be able to get the telescope on it. I can see it quite clearly, and I think we're just about going to have time to show it to you. But, of course, there's still a lot of drifting cloud up there, and we just can't tell whether it's going to be obscured at the critical moment. Of course, you won't see Vega looking large, because no telescope yet built will show a star.
It's gone,
Patrick. Is it gone? Oh, no.
Just as I got it on the crosswires, it blacked right out.
How absolutely typical. There's nothing we can do about it.
I can't move a 24-inch telescope quicker than that.
No, I'm afraid you can't. Well, is it worth keeping it there, do you think?
Well, there's nowhere else to point it, is there?
No, I'm afraid not. What I was thinking is if we're going to resign ourselves to seeing nothing more direct, then it might be a good idea to swing the telescope round into the camera and show the Gregorian mirror, which I think would be interesting.
Right, how?
Right, I think, then. Yes, we're rather restricted up here. There is a railing to prevent people from falling over, I hope. But, of course, not a lot of room for two. If we swing the telescope round and actually point it at one of the cameras, then you'll be able to see the Gregorian mirror in the end, which I think is probably worth doing. Yes, there it is, quite a nice view of it. Got any comments on that one, George? It's all right, it's just about clear of the rail. You can see the Gregorian mirror quite nicely.
Yes, but I can't get any closer to that camera.
Never mind, at least we can see it there.
For some reason or other.
Well, anyhow, that is that. I'm afraid we're not going to see anything more direct. We had hoped to show you Jupiter and Saturn rather more clearly, directly from Passion, but that just wasn't to be. And after all, we've tried 4 direct recordings now, and this is the first time when we haven't had real success. And anyhow, you have shown something, and we have at least been able to put Saturn direct on the screen for the first time.
Mind your head.
So, let's climb down once again. So I hope this has interested you, and I hope too that you've been interested in seeing this magnificent 24-inch telescope and George Hole, who built it. And so, from Brighton, where the sky is now completely overcast, good night.
Good night.